This is exercise 2.4.31, where we're told that the mean value of land and buildings per acre from a sample of farms is $1,500. So I've identified that mu is 1,500 with a standard deviation of $200. So I've identified that standard deviation sigma is 200. The data set has a bell-shaped distribution, which means it's approximately normal, like this. Assume that the number of farms in the sample is equal to 80. So I've identified that little n is 80. In part A of this question, you're asked to use the empirical rule to estimate the number of farms whose land and building values per acre are between $1,100 and $1,900. So in a normal distribution, which is a very symmetric distribution, the mean and median are centered at the middle. And in our case, the mean value is 1,500. We know according to the empirical rule that almost all of the data should lie within 3 standard deviations of that mean, within 3 standard deviations above to 3 standard deviations below. Each standard deviation, we were told, has a value of 200. So when we go up 1 standard deviation above the mean, we're going to be at $1,700 because 1,500 plus 200 is 1,700. If I go up 2 standard deviations above the mean, I have to add another 200 to the 1,700, and that gives me a value of 1,900. 3 standard deviations would be 200 more than that, or 2,100. Below the mean, and I'm only staggering those numbers so I can fit them in here. Below the mean, we are subtracting 200. So from the mean, 1,500, down 1 standard deviation would be 1,300, because 1,500 minus 200 is 1,300. And then 2 standard deviations would be 1,100, and 3 standard deviations below would be 900. So when we look at the question here, estimate the number of farms whose land and building values per acre are between 1,100 and 1,900. We notice that 1,100 is 2 standard deviations below the mean, and 1,900 is 2 standard deviations above the mean. Well, the empirical rule teaches us that within 1 standard deviation of the mean, we should find 68% of our observations. So if I go from 1 standard deviation below to 1 standard deviation above, we should have 68%. Within 2 standard deviations of the mean, we should find 95% of our data. And that's what we're looking at here for the $1,100 to $1,900 values. Within 3 standard deviations of the mean, we should find about 99.7% of our data. So if I go from, in this case, $900 to $2,100 per acre, I should find about 99.7% in there. So in this problem, we are within 2 standard deviations of the mean, the green. So 95% of our farms should be within that interval in terms of their value. So all we have to do is take that 95% expressed as a decimal, which is 0.95. We always change a percent to a decimal by moving it 2 places to the left, and multiply that by the number of farms, in this case 80. That would be equivalent to 76 farms that we would expect would have property and building or land and building values per acre between $1,100 and $1,900.